Welcome everyone. I am Swati from Sri Venkateshwara College of Engineering, second year, third sem. Now, I am here to explain about the concept of pipelining in DDCO. Now, let us start the session. The first part is Introduction to Pipelining in DDCO. Pipelining is a technique used to digital data communication and networking to increase the efficiency of data in transmissions. It involves breaking down of communication process stages of tasks that can be executed in parallel. The main goal of pipelining is to minimizing the time and increase the overall throughput of the system. Next is benefits of pipelining. Pipelining allows for concurrent execution of multiple tasks leading to faster data transmissions. It minimizes the impact of latency by overlapping the execution of different stages. Pipelining reduces the complexity of the system by breaking it down into smaller, more manageable parts. Next is basic concepts of pipelining. Data dependency. Each stage in a pipeline depends on the output of the previous stage. Instruction fetch. The first stage of the pipeline responsible for fetching instructions from the memory. Instruction decode. The second stage where the fetched instructions are decoded and prepared for execution. Next is basic concepts of pipelining conditioned execution. The third stage of the pipeline where the instruction is executed. Memory access. The fourth stage responsible for accessing memory location as needed. Write back. The final stage where the results of the instruction are written back to memory of registers. Next is instruction pipeline. In an instruction pipeline, each stage is responsible for executing a specific part of the instruction. The stages work in parallel, allowing for multiple instructions to be in progress at the same time. This increases the throughput of the system and reduces the overall execution time. Next is data pipeline. In a data pipeline, each stage is responsible for processing a specific portion of the data. The stages work in parallel, allowing for concurrent processing and faster data transmission. Data pipelines are commonly used in applications such as image and video processing. Next is hazards in pipelining. Structural hazards arise when multiple instructions require the same hardware resource of the same time. Data hazards occur when an instruction depends on the result of a previous instructions that has not yet completed. Control hazards arise due to branch instructions that change the usual flow of execution. Next is hazard migration technique. For forwarding allows the result of a previous instruction to be forwarded directly to the dependent instruction, avoiding stalls. Stalling passes the execution of instructions until the required resource of the data becomes available. Branch prediction predicts the outcomes of branch instructions as to minimize the impact of control hazards. Next is Pipelining in DDCO architectures. DDCO, distributed data communication and networking architectures, often employ pipelining technique. Pipelining improves the efficiency of data transmission and processing in DDCO systems. It enables parallel execution and reduces latency, resulting in faster and more reliable communication. Next is pipelining in DDCO architecture continued. DDCO architectures utilize pipelining in various components such as routers, switches, and data processing units. Pipelining enables concurrent processing of multiple data packets, improving overall system performance. It allows for efficient data routing, forwarding, and processing in complete DDCO networks. Next is pipelining challenges in DDCO. Synchronization, coordinating the execution of multiple stages in a distributed system can be challenging. Load balancing, enriching an even distribution of workspace workload among different stages of components is crucial for optimal performance. Fault tolerance. Pipelining techniques should be designed to handle failures and ensure systems reliability. Now we reached the last part of this session, that is conclusion. Pipelining is a fundamental concept in DD and CO that improves the efficiency and performance of data communication and networking. It allows the for concurrent execution, reduces latency, and increases the overall throughput of the system. Understanding the basic concepts and challenges of pipelining is essential for designing and optimizing DDCO architecture. Thank you for everyone for watching my video. Thank you.